Good morning, everyone. Thanks you for attending today's session and having me and all the sponsors who are making this event possible. My name is Chris Valentine, Chief Technologist for North America on the West Coast at Red Hat, and I've been with Red Hat for about 12 years working with strategic partners and customers along the coast. And today's talk is about continuous security with Kubernetes. I'll be talking about DevOps, some of the drivers behind it, as well as how Kubernetes enables DevOps, and then talk about some of the security implications of a Kubernetes containers-based environment. So does anybody recognize what this is a photo of? Close. All right, this is the Tesla automobile factory. The reason I show this is because software is a huge part not only of this factory and the production of the vehicles, but for the first time you can buy a car, drive off that dealer's lot, knowing the car will actually get better in 6, 12, 18 months down the road because they're able to deliver software updates over the wire. This allows Tesla to quickly respond to customer feedback and competition and deliver improvements to their vehicle long after it's been sold. When you look at the enterprise, though, are they able to respond that quickly to the market and changing conditions? No. Our stats show that 6 to 9 months is the average to take enterprise to deploy new applications. And what is the common process or the common themes that are driving, enabling the enterprise and kind of causing these roadblocks is that we see that there's walled-off silos or organizations, making it very difficult to move those applications from dev test into production. Also, these silos have evolved with their own set of processes and their own set of tooling, making it difficult maybe for the developers to communicate with the operations folks and vice versa, or the operations folks not being comfortable with the tooling that the developers selected. And so these types of challenges make it very difficult to move software quickly from dev, test into production, so a matter of months rather than a matter of minutes or hours in a DevOps type of environment. And so there's a lot of increasing pressure in IT to keep up and not become the bottleneck. And so you're seeing an evolution in how applications are developed, the underlying application architecture, as well as how they're wrapped up in a container, as well as the underlying infrastructure. You're seeing a shift away from waterfall development model to DevOps, a shift away from deploying monolithic applications to uncoupling them with microservices so they can rapidly be deployed, reduce the risk, as well as packaging these applications in a lightweight container that can quickly scale up, scale down, and be deployed into your infrastructure, whether it's private or public cloud. And there are a lot of companies out there that are early adopters of DevOps, whether it's LinkedIn, Etsy, or Amazon. But one of the common themes you're seeing is that as they adopt DevOps in their organization, they are able to improve the number of deployments that they're able to get out into production. They're having shorter lead times. They're having a lower rate of failure of deploying those into production. And when there is a failure, they're able to recover quickly from that failure. And so what is the enablers to DevOps? Right? It's not just technology. It's also a huge part of it is the culture. There's also process as well as the underlying technology. From a culture perspective, it's all about having an open organization or bringing together the different disciplines, whether it's a developer, a tester, a security engineer, and operations together in collaborating. Together having common goals and working as a team. From a process perspective, adopting continuous integration, continuous deployment with pipelines, enabling you to quickly move applications from development into testing to get immediate feedback as there is an issue, and then moving that application into production in an automated fashion. And then as you look at these early adopters, some of the underlying technologies that they're using, one of the common themes is that they're open source based in many cases, whether it's Linux and containers, the IaaS infrastructure, orchestration, and the development tools that they're using to make an automated software factory that allows them to have automated builds and automated deployments of their software. And containers are a big part of this new software factory in DevOps. They enable you to package your application once with all the immediate dependencies and deploy anywhere, whether it's dev, test, or production, physical, virtual, or private or public cloud. And the basics of a container is that you build your container, you can specify in a blueprint or a Docker file exactly how to build that so it's repeatable, and you can version control it from a security perspective as well. And then also, there's the concept of being able to then take that image and share it, right? Share it amongst your dev, test, and production environments so that that artifact remains exactly how the developers intended and built it in development. When you put it into test and production, it's exactly the same. You're not rebuilding, you're not reconfiguring, and you're not introducing that risk of change or error or a security issue as well. And then also running, right? Running that in a standard container runtime, using that standard container image format, and being able to run that on physical, virtual, public, private cloud. Think of similar in the Java world. You have a Java runtime, the JVM, and then you have the jar file, so you're able to run that code on the JVM. In container world, it's not just Java, it's any language or any application can be deployed in a container image and then instantiated at runtime. And how about continuous deployment, right? That's a key part of this new software factory. In a traditional CI/CD pipeline, you're typically building a jar file in the Java world and then sharing that artifact in QA, staging, and production. With the container-based model, the artifact passes along as a container image. And the difference is it includes all its dependencies, the base image of the operating system and any other dependencies or libraries that the actual container needs. So as I move that artifact into test, into production, I have all the same exact versions and those components that were built in development. And containers, container images, container runtime are great for an individual laptop. But what about the enterprise when you're deploying these applications that are containerized at scale, right? In a cluster on a private cloud or on a public cloud. And that's where Google took their internal technology and open sourced it as Kubernetes. Kubernetes is a container platform for automating the deployment of containers at scale, handling the networking, the storage, and the compute scheduling of your containerized application. And we'll talk in more detail about Kubernetes. OpenShift is Red Hat's open source upstream implementation of the Kubernetes and Docker. And so one of the things, with the containerized environment with DevOps is what about security, right? Traditionally, security has been an issue for your operations folks, right? They've managed the systems, they've gone and patched. What's the issue with that is that not all these security issues are actually tested in dev or test. They're deployed into production. And so with a DevOps environment, really DevSecOps, you really need end-to-end security. It's kind of a new model of embracing security in the culture, as well as in the process, as well as in the technology, in dev, test, and production. And Kubernetes is a key enabler to automating this capability in dev, test, and production. So let's talk about continuous security. A lot of issues and concerns around security when it comes to containers, and in a lot of key areas. And we're going to go through these. First off, CI/CD. Builds, content, registry, the container host. And then secondly, we'll get down to network isolation. We'll talk about storage API and platform access, as well as monitoring and logging, and federated clusters. So first off, CI/CD with containers. Here's a typical overview of the flow you'll see in a typical enterprise organization. They have their source code stored in an SCM with their developers and operations storing configurations as well as source code. Then you have your build in your development environment, your user and acceptance testing, as well as your production environments. These environments are mirrors of each other, right? In the DevOps world, one of the key principles is to give access to developers, give them access to production-like environments early in the process so that you resolve issues early rather than waiting to deploy that in a unique production environment. And Kubernetes is a key enabler to provide those mirror-like environments. And then you go ahead and build your container, and then you go out and deploy it into your environment. You'll save that into a registry, which will be the vehicle for sharing those images across dev, test, and production. And so one of the key things to a typical Jenkins continuous integration pipeline, as you're building your source code and doing these automated tests in a containerized based environment, what you want to do is kind of enhance that CI flow so that it also includes a security scan of your container image. Right? You can do this in a couple of different ways. Maybe you have a registry which automatically kicks off a scan, or you add a phase to your CI pipeline that automatically runs a container image scanner, such as OpenSCAP, which is an upstream open source scanner that can scan container images, virtual machines, or physical hosts as well. And this is an important step because now if you integrate it in your CI process, right, you'll be flagging whether there's a security vulnerability in that image right away in development and test, or is there an issue in terms of compliance to your security policy. So this scanner allows you to not only find security vulnerability, known security vulnerabilities, but also to check if it conforms with your security policy. And it is a great way to bring together operations or your security teams with the developers, ensure that everything that's going out of this software factory that's being built is also scanned from a security perspective. Also, continuous deployment. What are some strategies that you have in a containerized based environment to take this artifact and move it from dev, test, and production, and roll it out at scale? So Kubernetes includes some deployment strategies to make this an automated process, so you don't have to write scripts. Your developers can get out of the business of writing a custom development pipeline and leverage an out-of-the-box open standard solution such as Kubernetes. And one of those deployment strategies is really around A/B testing. With routing, you can do some A/B testing on a Kubernetes cluster. For example, in this instance, I have application A out in my production environment. 100% of the load is going to that application, and I'm seeing about a 25% conversion rate for that particular application on the click-throughs on the website. Now I've gone ahead and developed another version of this application, and I want to test it and see what the impact is. Or maybe this is a security fix, right? And I want to see, does this actually have a negative impact or a positive impact? Does it alter the business? And so in this case, I can easily, with Kubernetes, deploy application B and change up the routing so that 80% of my load goes to application A, version A, and then 20% goes to version B. So I want to gain confidence of this new security update, perhaps, in production before I go all in. And so Kubernetes has deployment possibility to actually deploy this in a 20/80 split. Once I am comfortable with this new version, I can actually then switch it over to 100% on application B. Another deployment strategy, we'll talk about how you have zero downtime deployments with Kubernetes. Right? In this particular instance, I have version 1 out into production on 3 different nodes. And I'm developing version 1.2. It's going through the CI process, through a new pipeline, through Jenkins. And once it completes its security scan and its testing, I can go ahead and do a rolling update. Right? So rather than going all in on this new version, similar to the A/B testing, but I'm actually going to deploy version 1.2 to 33% of my environment. Once I monitor and get feedback that that is a successful deployment, I'm not seeing a negative impact from a security or functionality perspective out in production, perhaps, I can then roll up to 66%, 100%, et cetera. And I don't have to write scripts, et cetera, to do this. Kubernetes takes care of this very simply. Also, it supports blue-green deployments. So Kubernetes can easily span up another environment completely separate from the existing environment. So the blue environment, for instance, is having version 1. I'm getting traffic on that, and I'm developing version 1.2. So I can go out and create an entirely new virtual instance of this environment, which contains 1.2. Within that separate environment, I can go ahead and complete my testing. Once that testing is successful, both from a security and functional perspective, I can do a complete switchover in my software load balancer that might be updating my F5 load balancer and route the traffic to then that new separate environment, virtual environment that hosts 1.2. And so this allows me to quickly roll back as well if there's an issue in that new environment. Maybe it's a security breach, and I can quickly revert back to the blue environment. Right, so those are deployment strategies built in and integrated into the Kubernetes container platform. Now let's talk a little bit about containers and security best practices as well. You know, one thing about containers is really to treat them as immutable. What does that mean? That means separating your code, your configuration, and your data. Right? From your code, that's the container image. That's where your application and all your immediate dependencies, maybe the base operating system image built for that container. And then from configuration, these are your traditional configurations. Maybe it's the data center location. Maybe it's a geography location. Maybe typically save that in a config file in the, on the system. Well, separate that out. You could use Kubernetes config maps, or maybe it's the password to access your MySQL database. In that case, you could use a Kubernetes secret to store that. And that goes into Kubernetes etcd distributed data store and allows you to have that separated from the actual container image. And then thirdly, Kubernetes certainly supports traditional data services. I see a lot of customers actually storing their data in their traditional, maybe Oracle or MySQL database that's outside of this Kubernetes environment for initial deployments. And then for newer applications, they may be leveraging the persistent volume support within Kubernetes to store maybe a MongoDB or some other scale-out type of database, or even a MySQL type of database, and contain that in the Kubernetes, or run that in the Kubernetes environment. And so persistent volume requests can be done by the developer and then fulfilled automatically by the Kubernetes environment, either in an automated or a manual perspective from the back-end operators. The other thing about containers is that, you know, what's inside that container matters. Your development organization may be pulling out images from the Docker Hub. Well, you might want to be concerned about what's inside that image that's being pulled into your enterprise. A while back, we ran a scan on all the containers, and we found that, you know, about 64% of them had a medium or high priority security issue, such as shell shock, heartbleed, et cetera. And so you want to be conscious of what's coming into the enterprise and have some sort of security process to scan them. And also you may want to consider about where they're getting the content from as well. And another thing is not just when you pull down do you need to be concerned, but on an ongoing basis. You need to be concerned about security as well. Take a look. These are a C application, a Java application, Node.js, and PHP from left to right. And these orange boxes are the different components that were pulled in when the Docker image was built. Now the triangle might be a little difficult to see the number, but take a look at the JRE here on the second column at the top. The number there is 66. And that represents that there's been 66 security errata notifications since the release of RHEL 7 for the JRE. Right? So my developer downloads it. You can be rest assured there are probably some security issues down the road that need updating. So I need to have a process to constantly monitor this. And that's why integrating the security scan in your CI process is a great idea to kind of catch those issues, or to integrate it with your private registry as well. Some best practices around building your Docker images, treat them as a blueprint, right? So that you have a recipe to rebuild that Docker image from scratch, right? Don't log into the live instance of the container, make configuration changes, and save it, right? It's impossible to reproduce or know what those changes were made later down the road when that engineer leaves and takes on other responsibilities. Also, version control your Docker files, right? Put them into a source code repository so you have those version controlled, those changes. And when you're specifying which components to use in your Docker file, be explicit with the version. Just don't put latest, right? What is latest? It could be different every time you run. Key is you want to be able to reproduce things, especially when it comes to security. Right? When there's a security breach in a PCI data area and you want to reproduce what logic was maybe run perhaps against that particular data set, you want to go back to that exact configuration, including that exact Docker image. And then be careful when you're using the run command in your Docker files, because every time you specify that, it creates a new layer as well. Also, some newer developments is around image signing, right? Sign your images. Red Hat provides support for image signing. There's many different solutions around this. And so Kubernetes integrates with image signing, providing the ability to detect, who provided the image, where did it come from, has the image been altered, right? So this provides another level of security. Another best practice, is building out a private registry. In OpenShift, we have an integrated private registry. Upstream, the DOWNTIME registry is available, which allows you to host your image registry within your firewall so that you know who's putting things in there, what's going in there, and providing role-based access control as well. So best practice, certainly in an enterprise type of environment, to set one of these up. It doesn't mean that your developers are restricted from going out to the public and pulling things down. You can definitely enable that as well so that you're not stopping innovation. Also, from a host perspective, what are some best practices around container hosts? Right? One of the key things is, when you install images, what you may not know is that that image is typically running as root. And in a container environment, if there's a security issue, it's running as root. They not only have root access to the hosts, but then they also have access to all the containers on that particular system. So you want to be very careful about what you're running your images as. Also, limit SSH access into these containers. Really go to an API type model where you're always accessing things via an API rather than logging into a particular container or host. And then also make sure using Kubernetes namespaces, whether it's networking, so separating out networks and isolating networks for one container to another, providing high security in a shared environment. You can also define resource quotas so you don't have that bad neighbor behavior, right? Preventing that from sucking up all the resources on a particular host and negatively impacting other containers. Logging from an auditing perspective, you want to have that enabled. Be sure to apply security errata, not just to the container image, but also the hosts that they're running on. And then security context and SecComp filters. This allows you to define policies so when containers or pods are initiated in the Kubernetes environment, it's well defined what the security context is from a user ID, group ID, et cetera, those containers are running as. And so Kubernetes provides support for that. And here's an example of the security context, right? It allows you to set those UID, GID, or SE Linux roles as well, and it'll apply those automatically. So this is a template that can be applied across your pod, and you can have different contexts for different clusters, et cetera. Right, so we talked about CI/CD, builds, content, registry, and container hosts. Now we also talk about network isolation, storage, API, monitoring, and federated clusters. Network isolation. So a great thing with Kubernetes and enabling DevOps is it allows network namespaces. Network namespaces are important because now you have network isolation from a security context in your different environments or your different containers. For example, you can set up a different network namespace for your development environment versus your testing versus your production. So essentially that means you have the same infrastructure, but 3 virtual different environments that are exactly the same. This allows you to enable developers to quickly spin up their own production environment in testing so that they're testing on a production-like environment. You don't need that standby data center anymore physically to test out changes in a production environment. And so this is a key feature that the enterprises drove and put into Kubernetes. Also, storage security, right? Kubernetes supports persistent volumes so that you can take your existing applications that are stateful and put them into a container, right? Even if you have your web app application with a MySQL data store, you can put that into a container. It doesn't need to be a stateless application that's newly developed. And so security context constraints allow you to limit who can access these storage volumes, as well as you have the ability to define quotas, right? So they don't negatively overflow the storage, and it's controlled in terms of how much storage they're requesting and being granted in these persistent volume requests. Also, these platforms are all API driven. At the Docker layer, the Kubernetes/OpenShift layer, you want to be able to not just have open access, but actually have authentication and authorization to these APIs and limit what folks in your enterprise can actually have access to do, et cetera. And so Kubernetes provides built-in support for role-based access control to the APIs so that you can define the policy and then limit what either a service or actually end users can be doing at the API level or the command line level as well. Another best practice is to take advantage of the built-in logging, right? So that you have an audit trail for what's going on in your Kubernetes cluster. Whether it's Kibana and Elasticsearch, these solutions actually run as a container on top of the Kubernetes environment. So they get all the same benefits for your other container applications, such as deployment, rolling updates, high availability, et cetera. And then also built-in monitoring, whether it's Prometheus or Heapster, Hawkular, on the OpenShift side with the Cassandra data store, you want to have access to all the metrics and have, from an ongoing perspective, historical perspective, but also have the real-time monitoring and logging capabilities so that you can search and scan for particular events or trigger events as well. and get a nice dashboard of your containerized cluster from a monitoring perspective and helping you identify security issues potentially as well. Another key capability that's under active development is around federation. Right? Federation is another key feature that, from a security context, allows you to kind of separate potentially environments. You may have your dev test environment out on Amazon, and so you could have Kubernetes running that. And then also, maybe internally, for your production environment, you want to have it on a private cloud, such as OpenStack. And so Kubernetes with federation can be deployed multi-clustered across these different infrastructures. Another implementation of federation is also you could have a single application spanning across multiple availability zones. In this case, the availability zones are different cloud providers, whether it's Amazon, Google, etc. And providing a global API to your Kubernetes cluster that spans across all of these environments. And so that's federation. So I want to thank you for attending today's session. Thank you for having me here at DevOps Days Vancouver. Really appreciate the opportunity to come and speak with you. I am available here today. I'll be around after the talk. You can also reach out to me on my email address or find me under Chris Vantine on LinkedIn as well. Happy to follow up and answer any of your questions on security, Kubernetes, containers, etc. Thank you so much.